Hello everyone. I wanted to work a problem, simple completing the square problem to help you out and get you started on the right foot here. And I think I'm going to do this one twice. The second time I'm going to show you a hack for doing this. This first time though I'm going to step you through the traditional textbook method that you'd find anywhere. And well, I'll start off though with a little bit more deeper insight. We call this a quadratic equation, and that's because it meets two criteria. Basically, it's an equation, of course, but also there's only one variable. In this case, it's t, and that's one criteria. And the other criteria is that the highest power on the variable is a 2. Now, quadratic comes from the Latin word quadris, meaning square. So you see how this all ties together. This is a quadratic equation. Now the technique of completing the square is a fundamental skill that we'll use actually later when we deal with parabolas. They help us isolate the essential qualities of a parabola for graphing. So it's good to get off to it on a good start. And what you need to do here is isolate the two terms with the unknowns in descending order, of course. And they're already in descending order. Now I could isolate them by creating some space here between them by simply moving the minus 3 way over to the right, or else I could isolate them by adding 3 to both sides. And that's how most textbooks would proceed at this point. So I'll add 3 to both sides. Now what we're going to do here is we're going to create a perfect square trinomial over here. The trinomial up here did not crack into two nice halves. It was what's called a prime trinomial, prime polynomial, or prime trinomial. So I need to create this perfect square trinomial. And there's a technique for doing that. We're going to basically be adding something here that creates that perfect square trinomial. And so what do we add? Well, there's a recipe for finding that number, that magic number. And what it says is you take the coefficient in front of the term that has the unknown to the first power. You rip it out and you bring it to the side of your paper. And you do two things to it. You divide it by 2. And then you square that result. And that is the magic number. Now when I divide 8 by 2 I get 4. When I square it I get 16. So 16 is the magic number that I add to create a perfect square trinomial on the left hand side. Of course, when you add 16 to the left side, since we're dealing with an equation here, you better add 16 to the right side. 16 plus 3 is equal to 19. Now this is a perfect square trinomial. It's equal to t plus 4 times t plus 4, which I'm going to write in shorthand style like this. T plus 4 squared is equal to 19. Our next move, the only way we can get this t out from underneath this square is to basically take the square root of both sides. And so that's what I'm going to do. The square root undoes squares. Now on the right side, since I've taken the square root over here, I better take it over here. And at this point in time what we do is we always insert a plus minus. And I'm going to talk about that because it's a bit of a magic trick right now. I'm going to show the necessity of that after I've solved this problem. Okay, the square root undoes the square, and we have t plus 4 by itself over here. On the right side we have plus or minus the square root of 19. We're almost done. All we need to do is subtract 4 from both sides. And we traditionally show that in front of this term. We write negative 4 plus the square root of 19. That's one answer. And negative 4 minus the square root of 19. That's the other answer. The quadratics all have two solutions. They may be the same solution repeated twice, but they all have two solutions. Okay, now what about this plus minus jazz? Where does that come from? To illustrate that, I'd like to use the simplest possible quadratic equation. Notice we have one variable, and notice the highest power is 2. So this is indeed a quadratic equation. And notice too that there are two solutions here that work. X could be 1 or x could be negative 1. Both of those will pop out a positive 1. So two solutions. Now the technique here to get x by itself is to take the square root of both sides. Now at this point in time, I'm deliberately not putting the plus minus here to show you what happens. The square undoes the square root, the square root undoes the square, and over here we have what's called the principal positive square root. This crunches out to just 1. And notice the answer up here of minus 1 has been lost. And that's why when we take the square root of both sides, we immediately put in this plus minus. It recaptures that lost solution. So that's why we have to do it. Now I wanted to also work a few other problems to help you habituate to this technique here of finding the magic number. So let me bring that in here. Here's a couple of more problems, and they're tailor-made now for completing the square. Notice that the x squareds are x terms are isolated over here, and what the technique says is you take the coefficient in front of the single x. In this case it's 6. You divide it by 2 and you square the whole thing. 6 divided by 2 is 3, and 3 squared is 9, and that is our magic number that we will add to both sides to create a perfect square trinomial, like so. Okay, now there's a nuance going on here in these first two that I've done that needs to be spoken to. The coefficient in front of the x squared term in every situation I've dealt with has been 1, and that is by design. That's a requirement. So when we look at this problem here, we notice the coefficient in front of the x squared is a 2. You can't complete the square unless you have a 1 here. So your first move here is going to be divide that away. And what you need to do is divide both sides, in this case, by 2 to maintain balance. It is an equation. So basically what's happening here is this division by 2 is being distributed to both of these terms. And the 2 will go into the 2x, the 2's will cancel away, and we're left with x squared, which is what we wanted. It has a coefficient of 1 and allows us to use the technique of completing the square. But don't forget this division. 12x divided by 2 is going to be a plus 6x. And over here we have 14 divided by 2 is 7. Please note that this is the same problem as I did when I turned to this page. I just altered it to show you this nuance that you must first always get a coefficient of 1 in front of your x squared term. And now to generate the magic number, well, this is the same problem. I've already done that. You rip out the coefficient in front of the x term, in this case 6, you divide it by 2 and you square it and you get 9. And then you add 9 to both sides. And so I didn't do that up here, by the way. That's interesting. I added 9 to just the left side, and that's a typical mistake. 9 plus 7 will give us 16. And then we have created a perfect square trinomial that cracks into two perfect halves, which we write as a square. And on this side we have 16. We then take the square root of both sides, which I'll do like this to save space. We remember the plus minus. The square root undoes the square. We have x plus 3 is equal to plus or minus, well, the square root of 16 is 4. And all we do is subtract 3 from both sides. So we have plus or minus 4 minus 3. And of course we're going to generate two rock solid numbers here. Plus 4 minus 3 gives us plus 1, that's one answer. A minus 4 minus 3 gives us a minus 7. And so there's our two answers. Both of those values will work in this equation and in this equation. So there you go. I worked basically two problems. I showed you how to generate the magic number. I showed you the necessity for creating the plus minus when you take the square root of both sides, and making sure that you carry that plus minus all the way through to the bottom. And I think that's it. Now I'm going to work this one again with a hack that I think simplifies it and streamlines it. I'll be talking to you again soon.